Okay, for this part of the test, part 1, the first 4 questions, there will be no calculator allowed and no index card. So make sure you know this backwards and forwards. The first 2 questions will be just to grasp the basic functions. So for this first problem, you're going to draw your own X and Y axis, just like on test 1. And you're going to make a table of values to help you put in the curve. Let's see, when I have an X of -2, that's 2 to the -2, which is the same thing as saying 1 over 2 to the 2, or 1/4. And then to the -1, similarly, will be 1/2. 2 raised to the 0 power. We know that anything raised to the 0 power, except for 0, is going to be 1. So any base raised to the 0 power is 1. And then I'll go ahead and do 2. 2 raised to the 2 power will be 4. So let me graph those points. Once you've sketched in your points, you can sketch in your curve, okay? And that's all I'm looking for, just to make sure that you have some points and that you are actually drawing the curve in correctly. Now, I'd also like you to draw in the asymptote. So you can just take your marker and draw in a dark line like this. See, I'm using dash just to make sure I can see it. That's my asymptote. Nice, you can refer to it later. And that would be y is equal to 0. So I've now drawn in my exponential function. Next, it asks me, what is the asymptote? Well, we already did that one. Y is equal to 0. And we're asked the domain. Well, the domain is as far left to as far right. We know as far left would be -infinity, and as far right would be +infinity. Range, what's the lowest point we can get to? Well, the lowest our graph will go will be 0. It won't actually get all the way there, though, so we'll put a parentheses there. And the highest would be infinity. So that problem's done. That wasn't hard. Let's try the next one. Same thing, I'm going to draw my X and my Y axis, and I'm going to label some points. Now, I want you to actually give me a couple points here, and some easy ones are 0. Well, we know 0 is undefined, so we're not going to use that one, are we? So we're going to use, how about 1? The log of 1 is 0. That's better. Let me graph that one. And then, what would be the log of 10? Well, we know that log, if you don't put any base, is 10. So let's think what that would be. So if I said the base is 10 and the exponent we don't know, and it's equal to 10, well, that would have to be 1. So the log of 10 is 1. So I can graph that in. And I know there's an asymptote right here. My asymptote is X is equal to 0. So we can sketch that in. Something like that. Okay, it's getting closer and closer to the vertical axis as you go farther, you go down. What is our asymptote? X is equal to 0. Now my domain, I'm going to go almost to 0 but never get there, so it's going to be 0 within a parentheses to infinity. And my range is my low value, which is -infinity, to my high value, which is infinity. That one's done too. That wasn't hard. And that's all I needed. A couple points, 1 and 0, and 10 and 1. Those are 2 really good, easy ordered pairs. For this next function, I want you to describe the basic function. And all I'm saying here is you just want to have it without any of the transformations. So h of x is equal to 6 to the x. That's the basic function. But if we transformed it, we're going to say, if you have a number on the, if you have the function we said, plus a number, that means we're going to go up c. And if you have a number and it's minus that number, you're going to go down. So in our case, we're going to be going down 8. Okay, it's a vertical shift down 8. Now, the next one is a horizontal shift, and you're going to look at the expression that's the x. So if you have the function that's x minus c, that means you're going to be going right c units. If it's x plus c, you're going to be going left c units. So in our case, we have minus 12. That means we're going to be going right 12. And you can write horizontal shift right, that's fine, or you can leave it alone like that, that's fine. We don't have any reflection because I don't have a negative in front of the x, and I don't have a negative in front of the 6. So I am done. Next one. So what's our basic function? This is just simply a log function. Describe the transformation. Once again, we have a number on the end by itself. It's a plus 9. That means I'm going to be going up 9. You can write that if you want as a vertical shift, up 9. That's fine. Either way is fine. And then the minus in the front tells us we're going to reflect about the x-axis. When the minus is in front of the function, it means about the x-axis. Had it been inside, let me just put it over here. Had it been over here like this would be about the y-axis. We didn't have that though. We had this one right here. It was a minus in front. So that's about the x-axis. Now we're done with that page. Then you're going to turn your test in. And now, yay, part 2. This one you get to use your calculator and a 3x5 index card. Remember, you can use a 3x5 index card and you can write on it both sides. So we have 2 functions. We have function A and function B. And we have to decide, are they one-to-one? Now, one-to-one, you can only be one-to-one, first of all, if you're a function. So let's look at these. Is this a function? Does every input only have one output? Well, let's see. None of our inputs repeat, so yes, that's true. Now I'm going to look at my outputs, and my outputs shouldn't repeat either. So 6, 7, 7, 9. Uh-oh, we've got a problem here. My outputs repeat, and they have different inputs. So 7 of an output has an input of 4, and 7 as an output has an input of 0. So this is not one-to-one. And to explain why, I would say because the output 7 has 2 different inputs. Now, another easy way to do this would be to graph it and then to say that it doesn't pass the horizontal line test. It wouldn't. So that would be a nice segue into our next problem, B. So this one here, we know it does pass the vertical line test, but you can see clearly that a horizontal line would have 2 places where it intersects. So this one is not one-to-one. And why? Because it fails the horizontal line test. And you are welcome to write HLT, if that makes sense to you too. Number 6, what is the domain of the inverse? Now this one is so easy to get confused and just not pay attention. It didn't ask for the domain of the function, it asked for the domain of the inverse. So we know that the domain of the inverse, right? Let's go ahead and write that inverse. We would take each output and make it into an input, right? So we know that our domain of our inverse will be those first coordinates. So 4, 8, 3, and -1. And I'm okay with not putting them in order. That's okay. Those are my domain of my inverse. Now I'm going to look at my range of my inverse. My range will be 0, 5, -2, and 1. Now, be very careful. It is so easy to not pay attention and grab the domain of the function. I didn't give you the inverse. You have got to make it yourself by flipping the x and the y coordinates. Now, our next problem, I gave you an equation and I asked you to find the inverse. So we know f of x is just a fancy name for y. To find the inverse, I'm going to swap the x and the y. And now I'm going to solve for y. Bring it over here. So I have x minus 4 is equal to 1/3 y. I'm going to multiply both sides by 3. And I'm going to get 3 times x minus 4 is equal to y. My last step is very important. Go ahead and cross out y and put the inverse of x, because that's what we're solving for. So you could leave it like that, or you could say 3x minus 12. I'm okay with either way is fine. Moving right along. Problem number 8. It says, what is f times g of x? Now be very careful. This is a closed circle. That means multiplication. A few problems later, we're going to have an open circle. See the difference? This means compose with. So back to our problem. This is just simply a multiplication problem, not a problem. So we know that when I have f times g, that's the same thing as saying f of x times g of x. So I'm going to say x minus 7 times 4x, which we know is 4x squared minus 28x. Now, what is the domain of f times g of x? So when we want to look at the domain, we just want to check out the original functions. Our original functions, this is a linear function and this is a linear function. We know linear functions, the domains are always negative infinity to positive infinity. Number 9, f minus g at x. And this is simply f of x minus g of x. So I'm just going to subtract the two. So I'm going to say 3x minus 2 minus 7x minus 1. Now, minus is the tricky one. I'm warning you. Plus is the easy one. Minus is the tricky one. With a minus, you need to make sure you distribute that minus to both members of the second parentheses. So I have 3x minus 2 minus 7x plus 1. And if I simplify that, I know I have like terms here. So I'm going to say negative 4x and minus 2 plus 1 will be minus 1. And my domain, just like the last problem, I have a linear equation and a linear equation, and both my linear equations always have a domain of negative infinity to positive infinity. Okay, let's look at problem number 10. The order of the letters is very important. This could be written as F composed with G. So we're going to take the output from G and we're going to put it in as the input of F. So if it had been G composed with F, then we would have used the output from F and put it into G. You always go from right to left. Ours, we're going to take our output from G and we're going to put it as our input now of f of x. So one way you can think of this is instead of f of x, you're going to put f of 7. Let's write it this way. Instead of f of x is equal to 3 over x plus 4, we're going to write f of g of x, because that's what's becoming the input, which we know is the same thing as g of x is 7x minus 1. And so I'll get 3 over 7x plus 3. Now, what is a domain? You have to be careful on these composition function questions. For these, you're going to always consider, first of all, what is the domain of this function? So what is the domain of g of x? Well, if g of x is a linear function, so our domain is just negative infinity to positive infinity. And now I want to check out the domain of this new composite function. Well, we know that a fraction can never have a division by 0. So we want to make sure that 7x plus 3 is always not equal to 0. So let's find out what x will make it equal to 0. I'm just going to solve for that. So we never want x to be negative 3/7. So for our, you could write that. That'd be fine. Or you could write negative infinity to negative 3/7 and put a parentheses and then say negative 7 to positive infinity. This means you're excluding negative 3/7. For problem number 11, I'm going to give you a graph of a line or a curve. I want you to graph and label the function inverse. Now we know how to do this. All we need to do is think this is 0, negative 2, and this is 1, 3. So what I'm going to do is I'm going to swap the x's and the y's. So instead of 0, negative 2, I'm going to write negative 2, 0. And instead of 1, 3, I'm going to write 3, 1. And you can see that I went ahead and labeled it, so I know it's the inverse line. The second part says graph and label the line of symmetry. The line of symmetry is always the same. It's always y is equal to x. That's the definition of an inverse function, that the graph will be symmetrical about y is equal to x. So if you're having problems, this was that basic identity function that we learned at the very beginning of the semester, where if you have a 0, it's 0, and if you have a 1, it's 1, and if you have a negative 2, it's negative 2. Whatever x is, y is. So I graph these points right here, and that's my y is equal to x, and that is my line of symmetry. You can see I labeled it nice and clear, so there's no confusion. Okay, question number 12. A company is offering a rebate of $30 and a 20% discount on dishwashers. The suggested retail price of the dishwasher is P dollars. Write a function R sub P that represents the cost of a dishwasher after the rebate. Now the rebate is strictly $30 off the top. So R sub P would just be P minus 30. The next part though says write a function D sub P that represents the cost of a dishwasher after the discount. The discount is 20%. Be careful. The price of the dishwasher would not be 0.2 times P. Think about if you had $100 and you got a 20% discount. You're not going to pay $20, you're going to pay $80. So we want d sub p. You can either write 1 minus 0.2 times p, and then realize that's 0.8 times p, or you can just go directly to 0.8 times p. Now, find d composed with r. And instead of being x, we're going to put a 200 because now we know that our input is 200. So what I need to first find out is what is r then at 200? So I know r at p is p minus 30. So I'm going to say 200 minus 30, which will be 170. So I'm going to take r sub 200 and I'm going to replace that with 170. So now instead of d sub p, I'm going to write 0.8 times 170, which will be 136. So the price of the dishwasher, if you go rebate first and then discount, is 136. This will be different depending on the order. So make sure you always do the right first. And then the output of that goes in the input of the left. And then it says, interpret this. What does this mean? Well, if this right here is your original price, the suggested retail price, it's telling you that for a dishwasher originally priced at $200, the price will be $136 if you apply the rebate first and then the discount, the 20% discount, or 30, is it 20%? 20% discount. And order is important, so make sure you always start with the right. All right, number 13. For the function 9 times 3 raised to the negative x is equal to f of x, is this increasing or decreasing? We know that exponential is a times b to the x is equal to y. And we know that if b is greater than 1, it's increasing. And if b is between 0 and 1, it is decreasing. So don't make this harder than it is. We just look at the b. Oh, wait, this is a tricky one because my problem says my exponent is negative x, but an exponential has a positive x when we're using these descriptions of b. So I need to make this be a positive x. To make an exponent positive, I move the base. So this could be rewritten as 9 times 1 over 3 to the x. Now we're going to look at our b, and our b is 1/3, which is between 0 and 1, so it is decreasing. Next, it asks us for the y-intercept. The y-intercept, no matter what type of function it is, we always know it's defined as x is equal to 0 because that's what a y-intercept is. It's a point where the curve or the line crosses that y-axis, and every point on the y-axis has an x equal to 0. So for this, we're just going to put in a 0 in for x. Okay, so any base raised to the 0 power is 1. So I'll get 9 times 1 is equal to f at 0. So 9 is my y-intercept. And you can describe it as 0, 9, or you could just say 9. I'm okay with either way. Okay, our next problem. You need your calculators for this one. So be sure if you need a calculator, you can go to building 4 in the middle and they'll let you check one out for a few hours with your ID. Okay, so we know that an exponential looks like this. A times b to the x is equal to y. We know that our y-intercept is always the a. So it's going to be 0.25. So I replace the a with 0.25. It's going to always be the y-intercept. If you can read it off the graph, that's super. Now I want to solve for b. And the way I solve for b is I use the second point they gave me. This is going to be x and this is going to be y. So I'm going to say 0.25 times b. I don't know what b is. I'm solving for it. And I'm going to raise it to the third power is equal to 6.75. Now, I can't solve for b until I get it alone. So I'm going to divide both sides by 0.25. And then I'm going to raise both sides to the 1/3 power, or another way you can think of it is you're taking the cube root. And when you do this, you're going to get that b is approximately 1.026. And if I don't list it, you can always assume you can just do 3 decimals for these exponential problems. That's fine. So I know what b is. That is not my equation, though. An equation needs to have the x and the y. So I'm going to rewrite this original equation as 0.25, and then I'm going to write 1.026 x is equal to y. So I'm going to use my a and my b to rewrite that equation, and this is our final answer. All right, number 15, write this as a logarithmic equation, okay? Oh, you're going to write this in exponential form. We're going to go the other direction. Be prepared to go either way. I'm not sure which way it was written. So we know a log is another name for an exponent. So here's a log. It's another name for an exponent. Log exponent. That's what it means, okay? And we know that the little teeny subscript is always going to be the base. That's why we read it log base A. So let's rewrite this. Base A exponent C is equal to B. A log is another name for an exponent. Let's do another one. So if you have a natural log, ln, we know the natural log always has base E. That's the definition. And it's another name for an exponent, so it's going to be B. E to B is equal to A. So don't forget, when you see natural log, we're going to assume it's an E. It's always going to be an E if you don't see it because it's a natural log. If you get a log of X and you don't have a base, we're going to assume it's a 10. Those are the correct assumptions. Okay? The next one says evaluate the logarithm. So let's rewrite it as an exponential. So base 3. Wait, we don't have it equal to anything, do we? Let's go ahead and write an x because it's unknown. So 3 to the x is equal to 1/9. What would x have to be to make this true? We know that 3 squared would be 9. Well, that's not right. We want it to be 9, 1/9. So if we do 3 to the negative 2, that means we're going to take this and we're going to move it to the denominator. And that's what I want. So x is equal to -2. Number 17, evaluate the logarithm using your calculator, log of 8/9. This is why it's going to be so important to check that calculator out if you don't have one. Check one out. They are available. They're free and they're in building 4 if you need one. Just go to the center kiosk in the middle of the building. Okay? If you're from a different campus than East, then go to your campus and they also have them available. Just ask. Okay? So here we go. We're going to say on, and then I'm going to say log. Now make sure if you close the parentheses. You're going to say 8 divided by 9, and make sure I close the parentheses before I hit enter. Now for these, I usually say round to 3 decimals, so it's going to be -0.051. That wasn't hard. Be comfortable with your calculator for the log, and be comfortable for the E, that Euler's number. It's right down here above the ln. Oops. So just give it a little heads up. If you're looking for the E, it's second, and then ln, and that pops up the E. If you need the value of E, you can put a 1 there, and it'll tell you that's what E is equal to. The natural log is right here, and then the log is right above it. So be familiar with your calculator. It will help you on this test. Find the inverse of the function. So inverses, we know how to do these. They're just like the last section. So we're going to just change out this for y. That's another word for y, f of x. And now I'm going to swap x and y. Step number 1 is always to swap x and y. Now I'm going to solve for y. But unfortunately, it's an exponent, so it's not as easy. But I can write it as a log. Log base 6 of y is equal to, wait, hold on, sorry, of x is equal to y. Remember, a log is another name for an exponent. So it would be log base 6 of x is equal to y. That's your answer. Oh, wait, before we're done, no, we're not. It's not your answer. Your last step always, since we're looking for the inverse, you would rewrite it as the inverse of x. That looks better. That's your answer. Okay, number 19. This is a function, and you can see it's been shifted. It's been shifted right, down 3 and right 7, right? We can see that. So if I had to draw a little quickie sketch, I could do that. But so we know it's a log. It looks like this, okay? That was the original one. Now I'm going to shift it right and up. So it's going to go right 7 and up 3, like that. So my asymptote moved with it. So you can see my asymptote was x is equal to 0, but now it's going to be x is equal to 7. Still going to be a vertical asymptote, but just going to move over. It's shifted right 7. That told me that. Okay, one way you can remember that is the x moves horizontally, it moves right or left. So you can look at this. And this is the one I told you don't really, it kind of is wonky because it says -7, but you're going to go right. Now for the domain, there's a couple ways you can do this. One is you can graph it and realize, oh wait, I can see my domain will be from 7 to infinity. Another way you can do that is you can just look at whatever you're taking the log of. Whatever you're taking the log of has to be greater than 0. That's the rule. So that would be x is greater than 7. I would accept either of these. You can either write it as an inequality or an interval notation. That's fine. Number 20, solving using the exponential equality property. I give you a little tip here. I'm actually telling you the easiest way to solve it. And that's to set the bases so that they're the same. Well, this one has a base 3 and this one has a base 27. They're not the same. So ask yourself, can I write 27 as base 3? What would I need to be? If you need to, use your calculator to help you. You'll see that 3 cubed is the same thing as 27. So I could write this as 3 cubed instead of 27. Now, this is a big mistake people make. We realize that we need to multiply these two, the 3 and the 3x plus 1. But for some reason, people forget to distribute it. So make sure you distribute it. So you're going to multiply 3 times 3x and 3 times 1. And I'm going to get 3 to the 9x plus 3. And the other side, 3 to the 2x minus 11. Since we're doing the exponential equality property, we know that when the base is the same, all we need to do is equate the exponents and then solve. So I'm going to subtract 2x from both sides, and then I'm going to add, I'm going to subtract 3 from both sides, and then divide by 7, and I'm going to get x is equal to -2. You could check this by putting it back into the original problem and making sure it's true. I would definitely do that on a test. It doesn't take but a minute. Our next problem says to solve using the exponential equation, solve the exponential equation. It doesn't tell you a method. And so you can use one of the two methods that we've learned in this class. I'm going to do both of them, but you don't have to. You can choose the one you like. The first method is just rewrite it as a log. I'm going to write log base 7. A log is an exponent. So I'm going to put the exponent over here. There. Now, when you use this method, you have to know the change of base formula. And the change of base formula says that if you want to change a base, you put the base on the bottom and the argument on the top. The way I remember this is base bottom. Put the base on the bottom. So I'm going to say log of 7. The base goes on the bottom, and then 246. Now, I could put this in my calculator and get a number, but I want x to be by itself. So I'm going to divide both sides by -4. And I'm going to get that x is around, remember it's not really exactly because we're rounding this, -0.707. Now let's do it the other way. So this is called method 1. And it's simply where you rewrite it as a log. If it had been exponential, you rewrite it as a log. If it's a log, you rewrite it as an exponential, and you might need to use a change of base formula. So you're going to need to memorize this one if you use this method. The second method is just that you take the log of both sides. So you notice I just added the word log in front of both sides, the left side and the right side of the equation. Now, if you use this method, you have to know the log property for the power. And it says that if you have a log with a exponent you could rewrite it as just putting it in the front of the log. So since we know that property, we're just going to move the negative 4x to the front. And now we're going to solve for x. So I'm going to divide both sides by negative 4 times log of 7. And you can see you're going to get the same answer. You're going to get x is approximately equal to negative 0.707. It's the same answer, just a different way to get there. This is method 2. And method 2 just says you just take the log of both sides. Now, if this had been a base e, then I would take the natural log. That makes it much easier. Natural log and e go together. Okay? Now we're going to go the opposite way. And you may use either method on problem number 21. I don't mind. We're going to solve the logarithmic function. On any of these problems, your first step is to get the log or the exponential function alone. So we're just going to use a little algebra and divide both sides by 22. So 11 divided by 22, that's 0.5 if you use your calculator. It's 1/2. Okay? Now we're going to use our rewriting it as an exponential. So I'm going to say base 5 raised to the exponent. A log is another name for an exponent. So I put the exponent here. And it's equal to the argument. So we know this is going to be, I could subtract 1 from both sides. And I didn't evaluate it yet, but I didn't leave it like that. And then I could divide both sides by 2. And when you use your calculator to figure this out, you're going to get that x is equal to around 0.618. If you want to use the other method for this, you can also do the same thing. So you take the base, and you're going to make that the base of both sides. Because we know that a base, when it's raised to the log of 5 to the 2x, becomes 2x plus 1. I'm going to have 5 to the 11 20 seconds is equal to 2x minus 1. This is the same from now on as we did earlier, and you're going to get the same answer. X is going to be around 0.618. And you're relying on this rule of logs, that when you have a base and you raise it up to the log with the same base, then you're going to end up with the argument. Okay? So some people like that method. You may choose which one you like. Let's look at problem number 23. This one is using the laws of exponents as properties. So you need to make sure you know the product law, the quotient law, and the power law. Okay? So just to remind you that the product law says that log of base a of x plus log of base a times y. You can rewrite that as log of a times x and y. Okay? And first law tells you that if you have log of a and you have x minus log base a of y minus, you can say log of base a of x divided by y. And the third would be the power rule, where you say log of a, the x. If it's to some number, let's just put n. You could rewrite it as n, put it in the front, of log of a to the x. And remember, these make sense because we know that a log is another name for an exponent, right? And think about it. If you have a to the x times b to the y, times a to the y, you add the exponents. You add the logs. And when you have a to the x divided by a to the y, you're going to subtract the logs. So it'd be a to the x minus y. Let me say that again. When you have when you have a to the x divided by a to the y, when you have like bases and you're dividing them, you will just keep the base the same and you subtract the exponents. Similarly, when we divide, we're really going to be subtracting the logs. So anyways, you might want to review those for the test. You can put them on your 5 card if it helps you. So I'm going to ask you to rewrite some as single logs. So this could be easy. I could rewrite this as log base 2 of x to the 5th. I move to the exponent position, minus log base 2 of x. I know that when I subtract logs, it's the same thing as taking those arguments and dividing them. So I'm going to end up with log base 2 of x to the 4th. Our next one. Rewrite this base 10. I'm just asking you to change a base. This one turns out to be a whole number, but they will not always be that, so make sure you can use your calculator. So I want you to remember the change of base formula, and I told you base bottom. So I'm going to rewrite this as log over log, and I'm going to put the base on the bottom and the argument on the top. Log of 4 divided by log of 2, if you use the calculator, will give you 2. It will not always be a whole number, though. And I'm telling you, typically on this test, I'm asking you to round to 3 decimal places for anything with decimals. Number 25. Find the cumulated amount if a person invests $15,000 in an account for 8 years at an interest rate of 7%. You must memorize these formulas. I will not give them to you. So we know that when something's compounded monthly, n, the number of times per year we do it, would be 12. It will change. N is the number of times per year that you're compounding. So I'll put 12 here also. T is the number of years. So in our case, it's going to be 8. R is the interest rate, which is 7. Now, remember, 7%, the word percent means divide by 100. So 7 divided by 100 on your calculator would be 0.07. Check it on your calculator if you need to. And then P is my principal. So I'm going to write 15,000 for my principal. So if I compound this monthly and I put this in my calculator, I'm going to get $26,217. Now, continuously is a different formula. You need to memorize it or write it on your card. Since there is no, they're not doing this, it's continuous, since there's no like number of times per year, you notice there's no N in this formula. Instead, there's only an R. So in place of R, I'm going to write our rate, which is 0.07. And in place of T, I'm going to write 8. Now we know E is a number. It's around 2.7-ish, right? So it's a number. Don't let it throw you. P we know already is 15,000. I'm going to use my calculator. Let me show you how to do that. Now, so I'm going to say 15,000, and then I have to find the E. To the E, I'm going to say second, and then ln, the natural log, and it gives me the E. And then up here in my exponent, I'm going to put parentheses, and I'm going to put 0.07 times 8. And then I'm going to close my parentheses. And I get 26,260. You can see that you make more money when you compound continuously versus monthly. And if this worked the other way, if you were borrowing money, you can see why the banks like to compound continuously. They're going to be making more money. Number 26, the number of Facebook users, millions, can be modeled by the function piece of t is equal to 1.53 times the base 2.82 raised to the x. Without graphing, is this function increasing or decreasing? Well, we know that this is simply an exponential function. I'm going to look right here at my b, right? My b here is 2.82. And we talked about that if b is greater than 1, it's going to be increasing. So b is greater than 1, it's going to be increasing. What is the growth or decay factor? Well, in this case, our growth or decay factor will simply be this b. So it's 2.82. I know it's going to be growing, first of all, because I just said it was increasing, right? So it's going to be a growth factor. Number 27, solve the exponential equation. Now this has an e. Don't let that throw you. An e is simply a number, an irrational number, but it's a number. So the first thing I want to do for any log or exponential problem that I want to solve is I want to get it alone. So I'm going to first subtract 1.5, and next I'm going to divide both sides by 2.5. Okay, now that we have the exponential by itself, we can do our magic, and we can rewrite this as a log. All right, so now there's two ways I can think of this. I can either write this as this log, and then put my base as e. My exponent is negative 3.1x. That's one way to think about it. But if I might just automatically realize that log base e is just natural. So that becomes natural log. If you didn't see that, you could use the change of base formula, and you're going to end up with the same number. Okay, but it's just a little easier just to write natural log of 13 when you realize that a log of base e is natural log. But if you did use a calculator, you're going to get the same number. Okay, and now I'm going to divide both sides by negative 3.1. And I get x is equal to negative 0.827. Now I want to show you the other method too. So if you're a person that likes the other method, so if you have 13 is equal to e to the negative 3.1x, you could also just take the natural log of both sides. Just like we did with the log of both sides, now I take the natural log. I take natural log this as an e. Okay, so I know that the exponent can come in front. Okay, now natural log of e, when you put in your calculator, would be 1. You could also reason it out, but that's going to be 1. So I'm going to divide both sides by negative 3.1. And once again, I'm going to get the same answer as negative 0.827. So really, both methods work, once again, the same as we did earlier in the earlier test. Now, last problem, find the inverse of a log. We can do this. We already know. We know f of x is a fancy name for y. To find the inverse, we swap the x and the y. Now we're going to solve for y. So how do we do that? Well, we rewrite it as an exponent. So I'm going to say base 33. We know that a log is another name for an exponent. Ta-da! And then my last step is always to be replacing the y with the inverse of x, because that's what we're solving for. So 33 to the x is equal to f to the negative 1. So 33 to the x is equal to the inverse of x.